Hello, and today we're going to graph the solution of the system of linear equalities. Y is less than or equal to negative 3x minus 3, and y is greater than or equal to the x plus 5. Nicely, both of these are in y equals mx plus b form if we think of these as just equal signs. So, first, this is less than and equal to, greater than, equal to, so both of my lines will be solid because it will include the points on the line. And then all we need to do is graph the lines in y equals mx plus b form. So we have y is equal to negative 3x minus 3. So I'm going to graph that line, and y is equal to x plus 5. So using some graph paper, I'm going to go to negative 3 on the x-axis. Then I'm going to count up or down 3 over 1. So my slope is negative 3 rise over 1. So that's down 1, 2, 3, and over 1. Down 1, 2, 3, and over 1. I could go back 1 and up 3 also. So that will be this line here. And I'll use this edge for a straight edge to draw my line. And there is my first. Whoops, missed some of the dots, but you get the idea. Okay, graphing y equals x plus 5. That's 5 on the x-axis. And my slope is the 1 in front of the x, which is 1 down, 1 over. A rise of 1. 1 up, 1 over. So I could go 1 back, 1 down, 1 back, 1 down, and that would give me the same as going up 1 over 1. Okay, graphing that line. Now, we want to go back to the inequalities that we're graphing. Y is less than or equal to 3x minus 3. This is the 3x minus 3 line, and all the points less than that line are all these points here. Then, y is greater than or equal to x plus 5, so that's the x plus 5 line. So it's all the points greater than here. So the solution is all the points that satisfy both, which is this double shaded in area. Now, you want to check a point. So let's go back to a point that's in this area, and that would be negative 6, 2. So let's check the point negative 6, 2, and see if it's correct for both of these inequalities. 2 goes in for y. So the question is this true? 2 is less than or equal to negative 3 times the x value of negative 6 minus 3. And is it true that y of 2 is greater than or equal to, that's a question, x plus 5. And the negative 6 goes in here. So this is 2 less than, this is 18 minus 3, that's 15. 2 less than 15, yes, that checks. 2 greater than negative 6 plus 5 is a negative 1, so 2 is greater than or equal to negative 1, and that checks. So this drawing is the solution, the shaded in area. In general, you will end up with graphs that chop it into 4 or more pieces, most likely, and you have to figure out which piece of the graph works for both or even 3 equations, and that's the overlap. So why don't you try it yourself? Try graphing the solution of the system of linear equalities. Y is less than 5x minus 3, and y is less than or equal to x plus 2. Okay, let's try this. If we graph y is equal to 5x minus 3, we need a dashed line here and a solid line here. So I'm graph these graphs and then make sure I change them, make sure they're dotted and solid as appropriate. So 5x minus 3, that's a negative 3 on the axis, y-axis, and 5 up, 1 over. 5 up, 1 over. So that would be this line. And y is less than or equal to x plus 2. Or, yeah, this is a 2 here. That's 2 on the x-axis, y-axis, and 1 up, 1 over, 1 up, 1 over, and that will be right about here. And then graphing that line, I get y is less than or equal to. Now, Math Excel is great because right at this point I forgot to make this a dash, so this is a dash line. So change that to a dash line if you were using Math Excel. And this is solid. That's less than this, so that's this area over here. And this is less than or equal to that, so that's this area over here, including this, but the answer is all this stuff right in here. So let's try 4, 0. Does that work for this graph? And yes, it does. Thank you.